So shall we start? Hi everybody, my name is Lubomira and I'm a member of Data Science Society. This is a non-profit voluntary organization with experience with more than 7 years actually in the field of Data Science Society, promoting and discussing topics such as machine learning. We are involved in various activities such as organizing meetups, hackathons, datathons, all sorts of events, beer gatherings as well. Actually, one of the things which are coming in the next months is actually group discussion and paper readings. If you want to find out more, you can always check out our website. On it, we also have a Slack channel, so you can keep yourself updated there. One of the things, as I said, one of the things that we do is organize meetups in which we discuss the implementation of data science in various fields. And today we are going to have a presentation regarding its implementation in media, especially assessing article embeddings. And Krum here is going to give us this presentation. He has an experience in the field of machine learning, data science, currently natural language processing, and now he is going to tell us a few words about Financial Times, the place where he is currently working, and also the topic. I give the floor.
Thank you. Thanks, Emilia. I will have a slide on the topic, but welcome everybody, those ones that are in the office, and hopefully some that have found the new YouTube link. My name is Krum. I will be giving a talk about creating and assessing media article embeddings in the next 1 hour. So go grab some drinks and some food to the ones that are in the office, and let's get on with it. First, some intro. I joined FT a couple of years ago. I work as a data scientist here. Previously, I was with a data science consulting company called Templify Analytics, and before that, I did something completely different. I worked kind of more of a business job as an account and ops manager at HP Inc. for a long time. I am mostly self-taught in machine learning through the various free online content, and honestly, I feel lucky that I'm working in a field that is so open, where the best of experts in the world are publishing everything that they have to say freely, where we can read their code. So it's a great field to be. My main hobbies, I used to do some music, interested in history and politics, but my current main hobbies are those two ladies here and their mother. Spent most of my time outside of work with the two princesses on the screen. And now I will talk a bit about Financial Times. For those who do not know, Financial Times is a big media in the UK and English-speaking part of the world. It's on the BBC level in the UK, really great journalism. But for all intents and purposes, Financial Times in Bulgaria is an IT company with a product. The office here is the biggest outside of London. In terms of data scientists, we're split between London and Sofia. 5 folks in London, 3 here, with 2 ML engineers supporting us. And we do not split between sites. We mix and match based on the project at hand. It's a rather diverse team in terms of backgrounds. We've got some PhDs in nanophysics. We've got business folks like myself and hardcore statisticians. And in terms of ML projects, we also work across the board, from the standard, like good old regression and classification, quite a lot of clustering and unsupervised learning, and also NLP projects with being in the business of publishing articles. In terms of main stack, we work both in R and Python, with our data being stored in BigQuery, but we probably will move towards AWS rather soon. And I'll open a bracket here. I know people kind of think badly about R, or I've heard comments that R is old-fashioned, too statistical, not good for production. I need to say that's not my experience. I'm not of that opinion. And in fact, the big query integration that I'm currently working on with R is, I would say, at least on par with everything that I've seen in Python in terms of lazy evaluation and query power. So R is cool. We shouldn't underestimate R. When we deploy on RStudio Connect or AWS, depending on if we deploy in batches or if latency is more important, then we go AWS. And one other point that I would like to make, the organization is extremely rich in terms of folks working with data. We have a huge BI and analytics community with experienced data-savvy subject matter experts, both here and in London. And same goes for the data platform and engineering people on the side. So both here and in London, a lot of people working with data. So all in all, a great place to be if you are interested in any data-related subject. All right, that's about FT. Now, what about the project at hand? So it's a collaboration between two FT teams, the data science team and a team called Content Analytics. And as sometimes happens in corporations, we had two things doing the same thing, more or less. The one team had a vectorization method based on doc2vec, another team had a vectorization method based on a transformer. We both were kind of happy with the methods that we had, but not entirely, and they were a little bit out of date. So we were using them in production in those 5 ways. So we had a metric about how broadly our subscribers are reading. We had some clustering models and a recommendation model based on the clustering, some trending topics thingy going on, and also a classification model. So some uses downstream. I will not talk about them today. I will stop short of the downstream effects, but all of this in production. And the goal of the whole exercise was, let's have one set of hopefully better vectors after the work is done. And yeah, the team to handle this task, 1 lead data scientist, 3 data scientists to do most of the job, and a very important ML engineer to support us. Now, I will go out of limb and start with the key takeaways, because it's late and people might get tired afterwards. So I want to move through the important parts now. Longish text vectorization in terms of important things to remember. You have plenty of great options nowadays. Like sentence transformers, doc2vec, put word embeddings, and TF-IDF are the ones that I'm going to talk today. But papers go out every single day. Yesterday, news Reimers, the sentence transformer author and the person behind the package, published a new paper for multilingual sentence transformer. Cool things are happening every single day, and it's a great place to be. But not all of them work well for long text. Long text is an unsolved problem, and people are working on it, so that's why it is cool. The text structure of the FT articles are making the problem a little bit more easy for us as data scientists, and there will be more about that later. And again, the no free lunch theorem is in place and it's holding firm. No single model is best in all the ways that you can use embedding, but the sentence transformers are rather good at everything, if not the best at most of the tasks. Almost the last point here is my advice would be to assess your embeddings the way you plan to use them. If you plan to classify things, assess them with classifications. If you plan, as we did, to cluster and classify and search things, you probably need 3 set of tasks for those things. So you cannot just do it one. And the last point is all the experts and the best folks on that and many other ML subjects are online giving their knowledge for free. So go follow them. In this case, my 2 recommendations are News Framers, the author of the paper for sentence transformers and the software behind that, formerly working at Hugging Face, nowadays at a company called Cohere AI. Yeah. And then the second guy is called Vincent Barmertan, and Vincent works on many ML tasks, but is currently with the space maintainers Explosion AI, and he just built good open source stuff, and we'll see some of his tools later this evening. All right, it's research time. Our project started with methods collection and let's find contenders, but in terms of research topic, it was let's find numerical representation of FT articles such that semantically similar articles are close. And I will add to that such that semantically dissimilar articles are further apart in the vector space. Both are important. And then to kind of set the stage for the topic, I would like to give an example of what semantically similar means. I would argue that there is no universal numerical text representation. And to give an example, those 3 sentences, nuclear energy is safe, nuclear energy is dangerous, and wind energy is safe. If we have the task to map 2 sentences, the 2 closest sentences together, which one would it be? Any guesses from the audience? So out of the 3, which 2 are the closest? Well, I would argue you can do the theory for any of the 2.
Nuclear energy dangerous, wind energy is safe.
Those 2 probably, we can argue that they are kind of furthest apart. But nuclear energy is safe and nuclear energy is dangerous are both very close and telling us the opposite things. Nuclear energy is safe and wind energy is safe is again closed on a different axis. So there is no single definition, and that's the cool thing. That's why we are in the ML space, because everything depends on the task. So there is no easy solution to the task we have at hand. And in terms of FT context, we had kind of a similar exercise to do. We have articles sometimes telling us completely different things, like UK and France reaching agreement over some dispute and then not reaching agreement over the same dispute. But probably those 2 are kind of closer to an article about theater and keeping the show on the road. So our task was, let's map the 2 together. Let's map that one about theater further apart and create a numerical representation about this. All right, so the NLP context of longish text is interesting. There are some challenges to it, as most of the research is focused on rather smallish text. And when I say small, I would say under 400 words. So when you have long text in general, frequently you have multiple topics per document. Like if you have a book and one article, one of the chapter is about a battle, and then in the next chapter, people are having a dinner or something. So 2 totally different topics in the same document. The transformers have a famous restriction usually up to 512 tokens, which are roughly 400 words in English. And I know that long former and big birds are around, but they are rather slow and they introduce their other set of challenges, so not really a solution. TF-IDF is out there, capable of long text, but if you want it to perform, it grows rather memory hungry, and we'll talk about that later. And Doc2Vec, the one that we had in production, is kind of okay, handles long text well, but it gets worse the longer the text. So not really optimal. But in terms of FT specifically, our job was it's kind of easier. And the reason why is, first, we have one topic per article. Then our journalists write nicely structured articles with no typos in there, so we don't have to worry about that. We also have the benefit of very descriptive title and a subtitle. So you can concatenate the two and you get a rather good summary of your article right at the beginning. So the 512 tokens is not such a terrible thing if you have a nicely structured summary at the beginning. Again, something that makes our job easier. Articles are using grammar structures that are very similar to the training data of the transformers. Very frequently past tense, all in all, in terms of grammar, not much different than the Wikipedia articles. So that's also something that kind of goes in our favor. And usually the articles don't pack a surprise element at the end. The authors usually try their best to say what they want to say at the beginning and develop it further. So the assumption of most of the information being in the first 400 words is not such a bad assumption in our case. Lucky us. All right, the contenders. We explored in our projects 4 contenders. And I'll start chronologically. TF-IDF, technology from the 70s. I was not born, my parents were born, but probably a lot of the audience was born as well. Footwork embeddings, a great baseline because they're ultra fast. Doc2Vec because we had it in production and it wasn't fair not to include it. And then centralized transformers and the million variants. And now the next 5 to 7 slides are all theory intuition. How deeply do we need to discuss it? Okay, who from the audience has heard about TF-IDF? Okay, so I'll try to be quick because it would be boring for everybody. All right, in terms of intuition, TF-IDF, again, invented in the 70s specifically for documents. So at least that goes in its favor. We have 2 things going on, a term frequency matrix. In this case, the example has Shakespeare plays, and the term frequency is how frequently a certain word appears per play in this case. The intuition being a word that appears in all documents is not helpful. So good appears in all plays, not really helpful. But battle appears in Julius Caesar and Henry V more frequently than in the comedies like As You Like It or 12th Night. So battle is helpful. Same goes with fool for the total opposite reason. Appears in the comedies, but not so much in the tragedies. So that's term frequency. Inverse document frequency, if we start with document frequency, if we say that Shakespeare had 37 plays in total, Romeo appears in 1 play in total, so its document frequency is 1 out of 37, and the inverse document frequency is exactly that, 1 over 37 or the log variant of it. So good and sweet get a 0 score because they're too frequent. Romeo gets a high score because it helps us find Romeo and Juliet. We multiply the 2, we get TF-IDF. So the hyphen here, that's not a minus sign. It's multiplication, and you get the score. Old technology, very well understood. A lot of things going for it. In fact, when I asked online, give me a recommendation about long text article, one of the industry experts suggested, is there any reason why a TF-IDF vector wouldn't work for you? That's a guy working at Spacey doing embeddings on a daily basis. Is the guy crazy? Well, not really. The TF-IDF is super fast. to train super fast to kind of score at inference. Very interpretable, covers the whole document, and in fact, it works better the longer the document. So if you have a tweet, it probably wouldn't make sense, but for our articles, it was a very nice fit. It has, unfortunately, some clear disadvantages. It is based on a vocabulary, and that vocabulary grows quite large. Scikit-learn stores it as a sparse matrix. The moment you try to convert it to a dense matrix, your memory explodes and you are in trouble. So that's a challenge. And then the huge vectors are for clustering. So we kind of knew that we will not choose TF-IDF at the end, but we wanted to test it anyway, partially because the industry expert told us to. All right, word embeddings. The reason why we have them in is that they are a great baseline. Super fast compared to the other methods. So very cheap to get a baseline on the tasks at hand. And quick slide about an intuition. For the ones very much aware about word embeddings, feel free to scrutinize the correctness of it. But we have some text. In this case, The Beginning of the Old Man and the Sea by Hemingway. We start with word number 1 and 2, he was. We skip word number 3, and we go to word number 4 and 5. So he was blank space old man. And we have a shallow learning network that tries to find out and predict what is the word in the middle. It needs to be shallow, otherwise the trick doesn't quite work, but I feel like it's a nice trick to have. Like you have a very shallow algorithm there, not very complicated. You have prediction about which you don't actually care, and the interesting thing happens in the middle. So our important word embeddings are kind of in here, and the hope there is that this algorithm will map similar words close to each other. So hopefully the guess here is either an or the, and then the algorithm will learn that an and the are similar words. Cool. That's a cool algorithm. 2004 and 13, so old in an NLP sense of the word. And hopefully the results look kind of like that. So a numeric representation, shark and fish for old man and the sea very close together apart from certain kind of minor differences, and then hopefully similar words clustered together. So again, we knew that this is not going to be the solution, but we wanted a reasonable baseline with cool tricks. If anybody wonders what's the put word there, well, you have only word embeddings, you need a document embedding. So at the end, the dimensions of the document embeddings, they need to be the same. So we need to find a way to map many word embeddings to the same dimension. We either mean maximum or min poo, but usually mean because we don't have time for to test the others. And an idea that we haven't tried, but actually we think that it might work, is combine the TF-IDF and the word embeddings and just weight the word embeddings by the TF-IDF scores and see what happens. There is a theory that might actually be helpful, but we don't have time to test it. All right, so super fast, good baseline, but weak theory about that it would work greatly for long articles. All right, next method. Doc2Vec, the one that we had in production for some time. More or less the same story with a tiny difference here. So the same folks with the word coming up with the word embeddings just added a document embeddings down below using the ID of the whole document and used the same algorithm more or less. And the backpropagation did its work, learning an embedding for the whole document. I don't know why it works. I cannot explain exactly why this should work greatly for document embeddings, but it works. And it's rather simple. And again, this is one of the many possible algorithms. This one is called continuous back of words, and you have skipgram, which is the opposite, but more or less the intuition holds. And this works. It's definitely not bad. We had things in production based on that worked greatly, past any A/B test out there. So why does it work? Well, and what's going for Doc2Vec? Well, it's really fast to train, fast to score. It's very specific to a dataset. There is no transfer learning going on here. You train it on your own dataset. It learns only from your own data. And it is built specifically for document embedding. So that's cool. Okay, I forgot about that one. It's one of the few algorithms in here that allowed us to play with embedding size. So you need embeddings of size 30, you just set it to 30. You need 300, set it to 300, and it works. So that's nice to have as well, I would argue. What's going against Doc2Vec? First big thing is it has a million parameters to tune, and you are not really sure what's going on. So the loss is not really helpful. So how do you choose how many epochs to train? What's the size of the embedding that's cool? Which of the many other parameters of the algorithm like if you're in an industry setting and you have a quarter to deliver, you cannot possibly test 50 variants of the Doc2Vec to come up with a most optimal answer. So, or you could, but you have other ways to spend your time. Something that we found out is that the GenSim implementation has a very annoying stochastic element to it. When you train a model and you score the same text 3 times, you get 3 different embeddings. And I'm not kidding. And the difference is minor, but still annoying. So that was not very cool. And not transfer learnable is also not great. All right, then there comes the big boys, and I want to know how we're doing with time. Somebody?